You guys, we're back with part 2, paper 4H for math from June 2010. Alright, we left off at question 10, and in question 10 they say these two quadrilaterals, ABCD and PQRS, are similar. Now what does similar mean? Similar basically means that their angles correspond with each other. So whatever angles they have, they'll be equal to each other, and that means their sides can be compared. So what it says is that AB corresponds to PQ, so AB corresponds to PQ, BC corresponds to QR, so BC corresponds to QR, and CD corresponds to RS, so CD corresponds to RS, and that means the other two should correspond with each other. So that means that these two angles should be the same, because where the blue and the green meet, they should be the same. Where the red and the these two angles should be the same, and so on. So you can just like fit in the things, the pieces. Okay, so 10a is asking you to find the value of x. Alright, now x is, it's over there, sorry, it took a while to find it. So you got to find the value of x. So first of all, you got to, when dealing with similar shapes, you have to compare it to the side in which it corresponds to. So since this x corresponds to 5.2, so you can say x is to 5.2. You can develop a ratio between them. And in order to find out the value of x, you got to take another ratio of two corresponding sides of numbers which you both know. And in that case, it's 4 and 6.4. So we can say, and by the way, this ratio is in the form of smaller shape, so smaller to larger shape. So we got to take the smaller side first, so 4 is to 6.4. So if I put this in algebraic terms, I'm going to get x over 5.2 is equal to, because the ratio will always stay constant between sides, is equal to 4 over 6.4. And so all we got to do is multiply both sides by 5.2. We're going to get x is equal to 4 over 6.4 multiplied by 5.2. And so x is equal to 3.25 centimeters. Now 10 asking you to find the value of y. Now you know that these two are similar shapes, meaning similar shapes have the same angles. So you just got to find the angles that correspond with each other. Now y is over here, and it's basically where the blue and the green lines meet. Now where in this shape does that exist? Where the blue and the green line meets. And it's this angle over here. So that means that these two angles must be the same. So that means that y is equal to 52 degrees. Okay, question 11 is really simple. They're asking you to simplify this fully. So in order to simplify, we can't just add these two fractions because they don't have the same common denominator. So in order to get a common denominator, what we're going to do is we're going to cross multiply. So in order to get a lowest common denominator, we got to cross multiply. So multiply this with this, multiply this with this, then multiply these two together, and you get a lowest common denominator. So we do 4 multiplied by x, and we get 4x, plus 3x multiplied by 6, which is 18x, and we divide that by 6 multiplied by 4, which is 24. And this is just a technique of getting a lowest common denominator, so you can simplify the whole fraction. So 4x plus 18x will give you an answer of 22x. So 22x over 24. Now 22 and 24 are both divisible by 2. So if I divide both by 2, so if I divide the numerator by 2, and not 2 divided by 2, so if I divide this by 2 and divide this by 2, this is going to simplify to 11x over 12. And that's the simplest form. Okay, so question 12a is trying to ask you to find the equation of the line L. Now this line L is a straight line, meaning it follows the equation, the general equation of straight lines on graphs, y equals mx plus c. So to find the equation of the line, we need to put it in this form. Except we need values of m and c. So c is the y-intercept and is basically where the line touches the y-axis. Now where is that over here? It's at 4. So that means that c is equal to 4. Now, m, the gradient, is not as easy to find. You can't just find it from the graph. Actually, you can, but like, you need values and you need points and stuff like that. So to find the gradient m, you need to do this technique called rise over run. So what is rise over run? So what you do is you take 2 points here. Okay, let's say you take these 2 points. Yeah, and actually just take these 2 points for the sake of simplicity. Yeah, and you kind of like draw a triangle, right? So the rise is this, and the run is this. Okay? So all you gotta do is take the rise over the run, and you'll get the gradient of this line. So the rise, if you look at it, it's 4 minus 0, right? 4 over here, and 0 over here. And the run, which is the length of this triangle, is 8 minus 0. So it's just 4 over here, and just 8 over here. So all you gotta do is 4 over 8, which gives you a gradient of a half. So, and that is m. So, you know that m is equal to half, and you know that c is equal to 4. So all you gotta do is plug it into the equation, the general equation y equals mx plus c. Meaning the equation of your line is y equals half x plus 4. But it's not just half x plus 4, because if the line was in this direction, it would have a positive gradient. But since the line is in this direction, all lines in this direction have a negative gradient. So it's y equals negative half x plus 4, or negative 0.5x plus 4, however you like to put it. Okay, question 12b, you're being asked to find the 3 inequalities that define the unshaded region, which is this region, in the diagram below. So first of all, what I like to do normally when I do these questions is label each line. So over here, this line, it is x is equal to negative 1, right? This line over here is the line we found in the previous question, which is y equals negative 0.5x plus 4. And this line simply, sorry, not this one, this one which I just shaded again, that line simply is y is equal to x. I'm pretty sure you guys know this because it's a straightforward line, because it's like going 0, 0, 1, 1, 2, 2, 3, 3. The points are like that. So they're, whatever, directly proportional, whatever you'd like to say. So your 3 lines are y equal to x, y equal to negative 0.5x plus 4, and x equals negative 1. Now, let's deal with this one first over here. We'll deal with this inequality. So, we don't want anything in this direction. The unshaded area, the stuff we want, is in this area. We want this stuff. We want all of this stuff. So, how do we make it seem like we want all the numbers on the right-hand side of negative 1? Well, it's pretty simple. All you gotta say is that x should be greater than or equal to negative 1. The reason for the equal to sign is because this is a solid line. If it was a dotted line, then it would just be greater than 1. So we've dealt with this one here. So we have one inequality here, which satisfies the thing, which is x greater than or equal to negative 1. Now, let's deal with this line over here. Now, we don't want anything over here, but we want everything above, right? So, we want all of that area, the above area. So, how do we make it seem like we want everything above? Well, it's pretty simple. All you have to do is say y greater than or equal to x, because we want everything that's greater than. Above. Think of when you go above the line, it's greater than or equal to, y is greater than x, okay? And when you go below, it's less than. Okay, so we have our second inequality, so that's done. Now, let's deal with the last one, y equal to negative 0.5x plus 4. Now, we don't want anything above the line, see, because this is the line, we don't want anything above. We want the stuff that's below, because we want this area, because the unshaded area is below the line. So, what the inequality is going to be is, since we want the stuff that's below, that means that y is less than or equal to negative 0.5x plus 4. And that is our third inequality. So if you combine all these inequalities together, you'll see that they'll all match up, and that means that this area will be satisfied by all three inequalities. Okay, 13a, you're being asked to solve this quadratic equation. So the simplest way of solving a quadratic equation is to first factorize it. Okay, so let's factorize this equation. Now to factorize this equation, what we got to do is think of two numbers that multiply to give me 1, because it's 1x squared, 1 times 12. So we're thinking of two numbers that multiply to give me 12. And we're also thinking of two numbers that add to give me negative 8. Alright, so two numbers that add to give me negative 8, and two numbers that multiply to give me 1 times 12, so 12. And if you just think about those two numbers, you're going to get two numbers which are minus 6 and minus 2, right? So what you're going to do with those two numbers is you're going to take this quadratic equation. I'm going to start here. So you're going to get x squared. You're going to split this into minus 6x and minus 2x, those two numbers which you found out. So minus 6x minus 2x plus 12. Alright? So now after you've split it, what you're going to do is you're going to factorize each side separately. So let's take this side and let's take this side separately. So we're going to get, in this, x is a common factor. So x squared divided by x is x, and minus 6x divided by x is minus 6. And on this side, the negative 2 is a factor. So you take negative 2 out. X is negative 2x divided by negative 2 is x, and plus 12 divided by negative 2 is negative 6. Now, you have to make sure that these two are the same, otherwise you cannot factorize further, and you've made a mistake somewhere. Now, what we're going to do is we're going to factorize the equation as a whole. Now, if you look at this whole equation, you can see that x minus 6 is what's common between the whole equation. So we take x minus 6 out, and what is left is x minus 2. So now we factorize this whole equation. So we've taken this, a little bit messy. We've taken this part and we factorized it into x minus 6 and x minus 2. And that all is equal to 0. Alright? Okay, so now we're going to solve for x. So what we're going to do is we're going to divide both sides by x minus 6. So what happens is if we divide both sides by x minus 6, divide by x minus 6, these two cancel. So it means that x minus 2 is equal to 0. Right? So that means that if we add 2 on both sides, we're going to get x is equal to 2. Now if we do the same thing, and in this case we divide both sides by x minus 2, we're going to get x minus 6 is equal to 0, and that means x is equal to 6. So your two answers are x is equal to 2 and 6. Question 13b, you're being asked to solve simultaneous equations. This is pretty easy. So in the first equation, which I've labeled 1, y is equal to 2x, and that's what the question tells you. And they've given you another equation, 4x minus 5y is equal to 9. Now these two lines are going to meet at one point. So in order to find out where they meet, all you have to do is, there are many methods of doing it, substitution, elimination, but what I'm going to do is substitution. So you know that y is equal to 2x. So all you have to do is take this y, and you can substitute it into this equation, equation 2. So what I mean by substitution is 4x minus 5. Instead of writing y, you know that y is equal to 2x. So all you got to do is replace y with 2x. And that is equal to 9. So expanding, you're going to get 4x minus 10x is equal to 9. And see, now you have everything in terms of x, and you can find out what x is. So 4x minus 10x is negative 6x is equal to 9. And dividing both sides by negative 6, we're going to get x is equal to 9 divided by negative 6, which is negative 1.5. Now we have a value of x. So all we have to do is take this value of x and substitute it back into any of the equations. So I'll substitute into equation 1, since equation 1 is easier to solve. So y is equal to 2 times negative 1.5, because x is equal to negative 1.5. And so y is equal to negative 3. So x is equal to negative 1.5 and y is equal to negative 3. And that's how you write it in coordinate form. Okay, so for question 14, you're being told that the area of the triangle is 6.75 and you're being asked to find the value of x. So to do this, you need to look at the note on the right over here. And basically the area of any triangle is half multiplied by a times b multiplied by sine of the angle in between the two sides. So looking at this example or this question, we have the two sides 4 and 6 and the angle between them is x. So the 4 acts as the a, 6 can act as the b, and the x can be the c in this equation which I've written here. And the area is 6.75. So the area is equal to half AB sine C. So it means that 6.75 is equal to half multiplied by 4 multiplied by 6 times sine x. Now all we have to do is solve this question to figure out a value of x. So 6.75, now if we multiply by, I'm going to do this really quick. So multiply both sides by 2 and divide both sides by 4 and 4 times 6. And divide both sides by 24 basically, because these multiply to give you 24, right? So you just divide both sides by 24. So you get is equal to sine x, right? So if I just write this in a simple form, you get sine x is equal to 0.5625. Now on your calculator, one sec, I'm just going to write this up here. On your calculator, you don't just divide both sides by sine. That's impossible. It's because sine is a function. So on your calculator, you have to solve for x. You need to do this thing called sine inverse of 0.5625. And don't worry, you'll find the sine inverse on your calculator. Basically, it's because it's a function. You can't divide both sides by sine. So you take the inverse function, which is sine inverse. And so all you have to do is x equals sine inverse of 0.5625, and you're going to get x as 34.22888, blah blah blah, but they want it in one decimal place, so you say x is equal to 34.2 degrees. Alright, so for 15a, you're given a histogram showing information about the heights of trees, of some trees, and they're asking you to calculate an estimate for the number of trees with heights in the interval of 4.5 to 10. Now it's an estimate, so like 4.5 is actually like really hard to decide from this, but it's like 4.5 would just be like somewhere there, like a little bit past that line, but it's an estimate, so we're just gonna take like it at that line, and till 10, so till here. So you're trying to measure the number of trees. So in a frequency density graph, the number or the frequency is basically the bar itself, okay? So it's basically the boxes in the bar. And they've kind of given you a key over here saying that these many boxes is 20 trees, alright? So using that we can figure out the number of trees. So all we have to do is calculate the number of trees in this area here. Okay, so now counting all the boxes in this area, you know that one of these boxes, meaning this one, is 20 trees. So 1, 2, 3, 4, 5, 6. So you have 6 boxes. And then you have 1, 2, 3, 4. If you count all of these little boxes here, you have 20. Right? And usually you have 25 boxes in this. So it means you have 20 out of 25. Plus 6 boxes. So you have 6.8 boxes, right? And all you have to do is multiply that by 20, because there's 20 trees in one box, and you're going to get an answer of 136. So that's all the trees in this area. Now, for this area, it's a little more complex, right? Alright, so this side is a bit more tricky. In this case, what I would suggest doing is counting the total number of boxes here. you'll actually get 1.6, okay? But then, you have to remember that it's from 4.5, so from 4.5, which is about there, till 6. And so originally it was from 4 to 6, the number of boxes you counted here, but actually it's been reduced to 4.5. So from 2, it's become 1.5, meaning this is actually 75% of the total thing, right? So what you got to do is multiply this by 0.75. Okay? So let me just make that clear. I'll just explain it again. So what we did was we counted the total number of boxes over here, but then we realized that we only needed from 4.5 to 6, so we only need this section, right? So from 4.5 to 6, that is actually 75% of this total box. So all we have to do is multiply 75% times 1.6 boxes, because there's 1.6 boxes here, and multiply that by 20. And what we're going to get is actually 24. So there's 24 trees in this area over here. Now we just got to add 24 to 136, and that'll give us a total of 160 trees in this whole area here. Alright, so for 15b, you're being told that there's 75 trees with heights in the interval of 10 to 13, and use this information to complete the histogram. So first of all, we need to know what frequency density is, because we're plotting frequency density against height. So frequency density is actually frequency divided by class width. Now frequency is the number of times something occurs, and class width is like 10 to 13 is the class width, 4.5 to 10 is the class width, 0 to 6, like this is the class width, so from 0 to 6. So in this case, we need to find actually like a labeling for the y-axis, so we can like plot a graph, because we have to plot another bar. Okay, so to find out the labeling of the y-axis, we need to find out the respective frequency densities of these bars. So in these bars, I've actually written down the frequency, and you can calculate from before you know how to calculate the frequency in each bar. So all we have to do is find out the frequency density. So the frequency here is 96, and the class width is from 0 to 6, so the class width is 6. So 96 divided by 6 gives you an answer of 16. So the frequency density for this is 16. So that means that this should be 16. And let's do it for this one also, this bar. So the frequency is 136, and the class width is from 6 to 10, so the class width is 4. So 136 divided by 4 is actually 34. Okay? So that means that this should be this is 16, and this should be 34. Alright? So now that we have like some kind of labeling, we can actually fully label this structure. So that means that this should actually be 20, this should be 30, and so on. So from 10 to 13, there are 75 trees. So that means that the frequency density should be 75, the frequency, divided by the class width, 3. So the frequency density should be 75, the frequency, divided by the class width, which is 10 to 13, which is 3. So 75 divided by 3 is a frequency density of 25. Now, all you have to do is, when you're plotting these bar graphs, you have to go up to 13, which is somewhere here. And 25 is somewhere on this length. Sorry if it's so messy. So all you have to do is kind of plot a bar graph. Oh, sorry. That was bad. Okay. And you have to plot a bar graph, and your bar graph will look something like that. So this is the new bar. I'll actually erase everything, make it simpler. Yeah, so this is it. So you see the frequency density is 25, and your class width is from 10 to 13 over here. And yeah, that's it. Yeah, so please watch part 3. Thanks, and comment, rate, and subscribe. Comment if you have any questions. I might not have explained the last question really that well, and I'm sorry for that, but just comment and I'll be able to explain it more thoroughly. So yeah, thanks.